Today we're going to be going over our osmosis and diffusion lab. When you look at the lab, you will see that there is a procedure and a materials and methods list on page 1 and 2. When you go through, you're going to see that you need 3 beakers, which I have right here in front of me, one of which will contain water, one of which will contain 30% molasses solution, and one will contain 60% molasses solution. These are your 3 different environments. They are going to surround a cell that we are going to make in order to run this diffusion and osmosis lab. Now each of these beakers are filled up to approximately the 200 milliliter mark, and these are 250 milliliter beakers. So they're all the same size. As we go through, we are going to see that we will also need some additional 30% molasses solution, and this is going to go into the 3 cells that we are making. These cells are going to look like this, okay? They're going to be a plastic tube filled with 30% molasses, and the ends are going to be tied off with string so they don't leak. Once I have this made up, I'm going to put them in front of the beakers on the paper towel you see displayed. Now I have to make 3 cells. To do that, I am going to be using something called dialysis tubing. I have it in this beaker right here, and this is plastic tubing. This is what the cell that I just showed you is made of. And we keep it in water in order to keep it moist. When it is moist, we can actually rub the 2 sides of this tube apart with our fingers. Okay? And this tubing does have little micro openings or pores in it that will allow certain molecules through and will keep others trapped on the inside. Now I'm going to take this and I'm going to leave about an inch tail on this particular piece of dialysis tubing. I'm then wrapping the string around it 3 times and tying it off. Okay. But if I leave it like this, I'm going to have a good chance of getting a leak. And so I'm actually going to twist the end of this tube, fold it over, and re-wrap it 3 more times with the string, and then double knot the string. This will help ensure that we don't have any liquid leaking out of or into the cell from the ends. And so I've basically made a loop at the end. And if I can show you that with my pen, you can see I can stick the tip of the pen through that loop. Now, as we continue along, we are going to fill this tube up. That is where my other beaker of 30% comes in, as well as the plastic pipette, which is right here. I'm going to take that pipette and I'm going to put it all the way down to the bottom and start squeezing out that 30% molasses solution. This is going to take several rounds. Now, if as I was doing this dialysis tubing started to dry out, the plastic won't be very flexible, and I would have just dunked it back into the water. That sometimes happens when we're in class because it can take a little while to make these cells. I'm told that I make it look easy, but I have years of experience filling up these cells. Okay, so I finished filling this cell. It has about an inch or 2.5 centimeters of space at the top, but there's no liquid. Now this is the tricky part, because now I want to do the same exact thing that I did at the bottom, only now it's filled with a liquid, and I really prefer not to spill that out. So I twisted the top a little bit and I'm holding it with my hand while I get another piece of string. I then take that string, I wrap it around 3 times, I tie it off, and I then take that top part, just like I did before, I'll twist it, I'll fold it over to make a loop, I'll wrap the string around 3 more times and then double knot it. Sometimes when we only single tie it at the end here, the knot will come undone, which is why I always recommend double knotting. Now we have a lot of string here, and you can see on my original one that I did cut the string, but I want about 1.5 to 2 inches, so about 4, 5, 6 centimeters long. And I'm just going to take my scissors and cut that off. Okay. This doesn't have to be exact, but I don't want to cut it too close or the knot can unravel. I'm going to make the third cell and then I'll show you what we're doing next. Okay, now I've made all 3 cells and we're going to go through what we're going to do with them next at the beginning of the experiment. The first thing we're going to do is submerge these in water. Normally we would do this at the sink in the lab, but what we are trying to do here is first off rinse off any sugar that may have gotten on the outside of the tube. And we're dealing with molasses mixed with water, and molasses is just a type of sugar. The second thing we want to do is get all of these strings wet. We are going to be weighing all these cells at the beginning and end of the experiment. And if I put dry string into liquid, that is going to increase the weight of the cell. I don't want that to happen. That will mess up my results. And so I just want to make sure that those are all nice and damp. So I'm going to do this with all 3. I'm putting them down on the paper towel. And at the end of this, I am going to just blot these dry with the paper towel. I wanted the outside to be wet or damp, but not dripping wet. Okay. So I'm going to just take my paper towel and I am going to just blot them dry really quickly. Okay. Again, I don't want these to be dripping onto the counter, but I do want all those strings and everything else to be damp. So I've done that, and at this point, I'm going to flip to my next page in my lab, which is page 3, and I'm going to see a table. I've copied down the first part of the table on this sheet. The first column will say the environment. That's what we put into these beakers. These are the environments that are going to surround the cell. And remember, we had water, which is labeled H2O. We had 30% molasses, which is labeled 30%. And we had 60% molasses, labeled 60%. Those are my 3 environments. And so that should be what you put in your first column. Now the next one says initial mass. And this is where we take out the scale. And I'm going to turn on the scale when it's flat on the surface. And then I'm going to put each of these cells on top of it. And you're going to want to record these weights. So the first cell right here is going to weigh, drum roll please, put it on the scale. It is 12.9. I am going to use that for the water environment. So that first one that says initial mass, you should put down 12.9. I'm now taking that cell and putting it in front of the water beaker. I don't want to submerge it into the beaker just yet because I want to do that at the same time. We want to control how long each of these cells is in the different solutions, their different environments. Take my second cell, I'm putting it on the scale, and that one is reading 11.3 grams. So I'm going to put that down for the initial mass for the 30% environment. I'm then going to take my last cell and weigh that. And that comes out to 12.5 grams. So I'm going to write that down for the 60% solution and put that in front of the 60% beaker. Now I do realize we do not have the same weights for each of these cells. That is not something we controlled for. We're going to see in class, after we get our final data, that we are going to change the change in mass between the initial mass we just took and the mass at the end of the experiment in 90 minutes, and we are going to come up with a percent change. So we're going to convert these numbers to percentages. Well, I now have everything in the beaker, or the beakers are set up, the cells are set up in front of it. I put the cell that goes in each environment in front of the beaker, and now I take all three of those and I submerge them into the liquids. And I want to make sure they're all poked down so that they are all covered in that liquid. And then I'm going to start a timer. Hey Siri, set timer for 90 minutes.
Okay, 1 hour and 30 minutes and counting.
All right, so I'm going to get a reminder in 90 minutes for when we will be checking this experiment again. In the meantime, you can look on the bottom of page 1 and you will see this setup diagrammed for you, and you have to write in that diagram the 3 different environments in the boxes you see, and then the solution that we put inside each of these 3 cells. I'll give you a hint, it was the same solution. So remember back to the beginning of the lab and remember what solution we put inside. It's also in your procedure on page 2. Now, at the bottom of the illustration, you'll see a line underneath each beaker with cell inside that you've just labeled. On that line, you want to write down if this solution is hypotonic, hypertonic, or isotonic. And I will see you again in 90 minutes. Welcome back. 90 minutes has passed, and we're now ready to look at the 3 cells that are found in our 3 different solutions here. The first thing we want to do is take them out of the solutions, and we want to do this all at the same time so they spend the same amount of time in each of their 3 environments. So I'm going to take the cell out of the 60% solution. I'm going to take the cell out of the 30% solution. And I'm going to take the cell out of the water. All right. And as you can see, there can be some pretty major differences in what these cells actually look like. Now, we do want to make sure that we rinse off these cells. Again, in the classroom, we'd normally do it in water from the sink, but today we're just using water in this container. So just rinsing them off, and then I'm going to pat them dry. Okay, pat one dry. I'm gonna do the same thing with the second one. Pat it dry. And I am going to do the same thing with the third one. Okay, the one that was in the water. Even though it was in the water, I still want to keep everything the same and keep everything consistent. Okay? Because we want to control all of our variables. All right, I'm going to start with the one in the water. And when we look at our table that we put the environments on and the initial masses, we're now going to get those final masses. And we have our scale once again. And I'm going to just turn it on and make sure it is flat on the surface. It is at reading 0.0 grams. So I'm going to take the one that was in the water first and put it on the scale. It is now 13.0 grams. So it hasn't changed much. The initial mass was 12.9. I'm going to take this one that was in the 30% solution, put it on the scale, and it is reading 11.0 right there. I then took our third bag, which either really had a lot of liquid leave it or there was a leak. I'm putting it on the scale, and that is now weighing a mere 6.4 grams, down from 12.5. Now, just for fun, I am going to put these back into the solutions, And I'm gonna leave them overnight and we will see what they look like in class. All right, so I wanted to leave these different bags, the cells, going a little bit longer. And I've already gone ahead, rinsed off the cells, blotted them dry, and weighed them. And I wanted you to see what they look like. So here is the cell that was in the water. And this has been in the water for a total of 9 hours and 15 minutes. When I initially weighed this, it was 12.9 grams. After 1.5 hours, it was 13 grams. And now it is all the way up to 13.5 grams. And you can see it's a pretty firm cell. The next one was in the 30% solution. It started out at 11.3 grams. After an hour and a half, it was down to 11 grams, but then it held constant. And it's still 11 grams after 9 hours and 15 minutes. And this is something you can talk about in your report about why it initially went down 0.3 grams. Now the next had changed quite drastically. At the initial mass for the 60% solution, we had 12.5 grams, and then it went down to 6.4, and we could see it looked like the bag may have even leaked. But I wanted to show you that it didn't, because even after 9 hours and 15 minutes, it went down a little bit further to 4.9 grams. But I put another one in, and this one was in for a total of 7.5 hours, so a little bit less. And you can see that this one also lost a lot of weight. This one started off at 13.5 grams, and after 7.5 hours, it was down to 5.9 grams. And I did this again to show you that the cell was actually losing a bunch of liquid and actually had not sprung a leak.